Hello everyone, for this video we will look at this LCD I2C module that can transform this very messy circuit from this into this. And let's check out the hardware. If we will compare the two from the front, so it's the same. They have almost the same exact pins, actually exactly the same pins, also the same size, but when we look at the back, you can see the difference. There is an additional module added in here. It's just connected at the same location with those pins, and this is the part that transforms this module into this. So instead of the parallel connections with your data pins in here, the data will be going through this data pin. So let's put this one aside and look even deeper into this. These jumpers are for the LED backlight. We can control it with a power supply, or we can just put this jumper. Once this jumper is installed, the backlight will be on by default. This one here is in color blue, is a potentiometer. It controls the contrast of this display. We have the pins here: ground, VCC, SDA, and SCL. We have this A0, A1, and A2. These are solder points that we can use to change the address of this module. By default, this module is set at 0x27. By default, we have here high, high, high. So all these three are set to high because bridging these two solder points will bring it down to ground, so that will make it into 0. So this is 1, 1, 1, all high, and that is equivalent to the address of 0x27, or that is 39 in decimal. So if we want to change the address of this, we need to solder these 2 points together to make different combinations. We'll look at it later. So I will connect it back to our Arduino and let us see some programming examples. So the connection is very straightforward. We'll have to connect the ground and the VCC, that's for 5 volts and ground. But if you will check here with our Arduino on top, we will check our Arduino here from the top view. We cannot see any connection that corresponds to SDA and SCL. So maybe let's check the back. So if you will check now at the back of our Arduino, you can see now that there are pins SDA and SCL. So it corresponds to these 2 pins on the long header. So this and this for SDA and SCL. These SDA and SCL pins are also connected hardwired into these two. This is the A4 and A5 there, A4 and A5. Take note that A4 corresponds to SDA and A5 is also used as SDL. I will be using A4 and A5 for this connection because it will look much clearer. It's there. Let us connect our Arduino cable. The program is still uploaded. There. So from here, we will head on to our IDE and let us check the programming. So here in our IDE, we have the simplified version of the Hello World program from the Liquid Crystal I2C library. So we can go to this program or sketch from File, Examples, and then we have Liquid Crystal I2C, and we have this Hello World. So this program is taken from that. This sketch is taken from that. I have just shortened it for clarity. Line number 1, we can see that we have to include liquid crystal I2C point H. So this is the library that we need. line number 3, we have the liquid crystal function. The liquid crystal I2C function needs 3 parameters. So these 3 parameters are this 0x27, 16, and 2. 0x27 stands for the module address, that is by default, as I have said earlier. 16 tells that there are 16 columns in our screen, and 2 tells that there are 2 rows of characters on our screen. For our setup, at line number 7, we have LCD.init to initialize our LCD. We have LCD.backlight to turn on the backlight of our LCD. Line number 9, LCD.setCursor, which places our cursor at column 0, row 0. So that is the leftmost on the top left position of all the characters in our screen. And we have LCD.print hello world, which is printing these words between the quotation marks, hello world. So hello world is a string, so as we print it, it will be just printed as the same. For our loop, we simply set again our cursor to the second row, first position. So column 0, row 1. So we have now it at 0, 1, and then at this point, starting from this point, we will be printing our millis divided by 1000, and that is the number of seconds now from the previous restart or the previous reset of our Arduino Uno. So let us try to make some changes to our code and see how our display reacts. The first one that we will check out is line number 8. I will switch off the backlight by changing this word backlight into no backlight. Take note that we must capitalize letter B in there. Now let us upload it and see what happens to our display. So as we can see, it's now off. The backlight is off, but it's still working. So if we don't want it lit up, we can just give this command lcd.nobacklight. So the no backlight command. Let me put it back to the original. This set cursor function in here is telling us where the cursor will be placed. So at 0, 0, that is the position of H over there, 0, 0. Now, if I want it to move one place to the right, I will just change it to 1 now. So this H is 0, 0, this E is at 1, 0. So our hello world will be starting there. Let's see what happens when I upload it. So as we can see, our H has moved 1 character to the right. There might be times that we need to clear the contents of our LCD, and to do that, we can give the command lcd.clear. So in our code here, I will give it a delay of 5000, which means there will be 5 seconds that the hello world will be printed, and after that we will clear it out by this function clear. So lcd.clear, we are clearing our LCD. Let's see. So let us see it in action. So there, hello world, 1, 2, 3, 4, 5 seconds, and after that the hello world is cleared, and then it started now showing our this part of the code. It is printing now only the millis because that part has been cleared. Now let us go back to line number 3, and as what we have talked about earlier, this line number 3, with the liquid crystal I2C function, we are feeding it with 3 parameters. 0x27 stands for the address of this module. Yes. 16 tells us that we have 16 columns, and 2 means there are 2 rows, so that is the size of our LCD. Now let us see what might possibly happen if I change this 0x27. Let us say I made a mistake. I told that the address is 0x20, and let me upload this. Okay, so as you can see, after uploading, hello world is still there, 55 is now there. Our module now is not working anymore. What is being printed is just what's in its memory. So let me remove the power for that and connect it back. Let me try to upload it again. So the program is now uploaded to Arduino, but there's nothing that came into the module. So how do we know the address of any I2C device? So we can just do the same. You can connect it to the Arduino just like this. Put the supply and put the SDA and SCL pins. And in order to get the address, we may look here. We can head over to our IDE. We can go to File, Examples, and we will go to our wire. And at wire, we will go to I2C scanner. So click I2C scanner. Okay. And then what we will do is we will just simply upload this to our Arduino. Just like so. Let me click upload. And as you can see, nothing is happening to our module. It says compiling sketch, uploading. Okay, and finally, when it's done uploading, nothing happens to our module. But what we can do is we can go to our serial monitor, and from here it will tell us about the address. Okay, so I guess that's all that I can say for this module, the I2C LCD. I hope you learned something from this video. If you are not yet subscribed, please kindly subscribe to the channel to help us grow and even help reach out to more Arduino enthusiasts. Thank you for watching. If you have any questions, any comments, or if you want any other module discussed or anything regarding Arduino to be clarified, please post it in the comments. Thank you for watching. Bye bye.